circle diagram, and we will solve the numerical that is given as a 415 volt 29.84 kilowatt 50 Hz delta connected induction motor. The test gave the result 415 volt 21 ampere, power 1250, and block rotor test is 100 volt, current is 45 ampere, and power is 2730 watt. Here we have to calculate. First we have to construct the circle diagram and determine the line current, power factor of rated output, the maximum torque, and here given as the copper loss and the rotor copper loss are equal at standstill. We know that the power formula P is equal to root 3 VL IL cos phi. That is cos phi is equal to P by root 3 VL IL. For no load test, here given as V naught is equal to 415 volt, I naught is equal to 21 ampere, and power as 1250. And the power factor at no load. The power factor at no load will be power divided by root 3 VL IL cos phi. Power is here 1250 watt divided by root 3 into VL, that is 415, and V naught equal to 415, I naught equal to 21. After calculations you will get the value, that is power factor equal to 0.0918. Power factor equal to 0.0918. Hence we can calculate the angle. Phi naught is equal to cos inverse of 0.0918. That comes out to be 84 degree. Similarly, here VSC is given as 100 volt, ISC is 45 ampere, and power at short circuit 2730 watt. Same formula here we can find the power factor at short circuit, that is equal to power 2730 divided by root 3 into 100 volt into 45 ampere, that is equal to, that will comes out to be around 0.3502, 0.3503, and pi SC, that will be cos inverse of 0.3503, that will be around 69.3. So here we have to convert the short circuit current into normal rated current, that is ISN. If the normal rated voltage will apply at short circuit, then we will get the current that is equal to ISN, and the formula for that will be ISC into full voltage divided by short circuit voltage, that is equal to 45 into 415 by 400, that is equal to 186.75 ampere. So first what we have to do in constructing the circle diagram, here we are getting I naught is equal to 21 ampere. After calculations we get the value that is power factor on no load, that is equal to 0.0918. From there we get the value of phi naught equal to 84.44. Likewise, we also get the value of phi of n, that is equal to 69.30. The short circuit normal up to now applying normal voltage, we will get that is 186.75. Let us take a current scale B 1 centimeter equal to 10 ampere. So now calculate the distance, that is equal to 21 ampere divided by 10, that is equal to 2.1 ampere. For no load current, that is 2.1 at an angle of 84. So first we will draw OO dash of length 2.1 centimeter and at an angle of 84.4. Next we will draw ISN, that is 187.65, having a scale of 1 centimeter equal to 10 ampere. After dividing 186.75 by 10, we get the value 18.67 at an angle of 69.30. Here we have drawn OA, there is ISN 18.7 centimeter at an angle of 69.3 from y axis. Now we have to draw O dash A by dotted line. Now this blue line O dash A is your output line. Now we have to draw a parallel line with x-axis through O dash. After that we have to bisect O dash A by perpendicular bisector method. Intersecting point at this line is named as C. And now we have to draw a semicircle by taking C as a center. We will draw semicircle by using radius as O dash C and C as a center. Now we have to draw a parallel line from y axis towards x axis from point A. Now here in the questions already given is, we have to assume that rotor and stator copper loss equal at standstill. That means the line AH is equally divided, and either we can also do the angle AO dash H and bisect the angle and connect to the point. Either in any way we will get the midpoint of A and AH. So we will get a midpoint so that AM and BH will be equal, as both the losses are equal. Here power at short circuit equal to 2730 watt given. So short circuit power at normal voltage will be power at short circuit into voltage square divided by short circuit voltage square. The PSC equal to 2730 and rated voltage is 415 and short circuit voltage is 100. That comes out to be 47,000 watt. Already here GA is, that is power line is now extended to 4.19 as per the output, and we have calculated in power scale, that is 4.19 centimeter. Now we have to draw parallel line with output line. We have to draw parallel line with this output line, and the intersections point will give P. It is parallel line with output line with respect to. Now after joining the point O with P, we will get the current value. The line OP is the line is the current, it is phase current, and the angle EOP, the angle EOP will be the phi angle, that is the power factor. So for getting power factor, we have to just cos of POE angle. Now OP is measured as 6 centimeter, and 1 centimeter equal to 10 ampere. That means that comes out to be 60 ampere. As already we know that in the questions that here given as it is a delta connected network. So converting this phase current into line current, we have to multiply root 3. There is root 3 into 60. That comes out to be 104 ampere. And also here this angle is around 35 degree. That is equal to power factor will also equal to cos of 35 degree. That is equal to cos of 35 equal to 0.81 Now we have to again find the value of maximum torque. That means for getting the maximum torque, this is your torque line, this is your output line, to get the maximum torque, we have to bisect the torque line, and the intersections point of semicircle will be your maximum torque. J. Now after connecting parallel line with x-axis, the intersections point will give you the maximum torque. The line JK will give you maximum torque. JK, the maximum torque is equal to 7.3 centimeter. Hence maximum torque is equal to 7.3, and already we have calculated 1 centimeter equal to 7120, that is equal to 51,000 simple. Alright. Likewise, now after connecting this point with this line, you will get the maximum power.